Okay, find the roots of x cubed plus x plus 4x squared minus 6 is equal to 0 by factoring. Quick way we can do this, I'm going to say f of x is equal to x cubed plus x plus 4x squared minus 6. And if we want to determine some potential factors, you can use factor theorem. Now, in order for me to use factor theorem, the remainder theorem of a value has to be equal to 0. So the remainder has to be equal to 0. So in this case, I want to figure out some potential factors. So potential factors, once again, you can use this formula to ballpark some of your guesses, but once again, it is trial and error. So you do plus minus the constant term, factors of constant over plus minus the factors of the leading coefficient. Right? And you want to think about your function f of x in the form of ax cubed plus bx squared plus cx plus d, right? So in this case, our potential factors are plus minus factors of 6, right? So you could do 1, 2, 3, and 6, and leading coefficient is 1, so plus minus 1. So our potential factors that we can test out are plus minus 1, 2, 3, and 6. You just divide all of these numbers by 1, right? Now, I'm going to test one of these values out. I'm going to start with f of 1, and you get 1 cubed plus 1 plus 4 times 1 squared minus 6. And we actually got lucky here, and we actually figured out that f of 1 is 0, so x minus 1 is a factor, right? So now what we want to do, if we want to find the rest of the factors, we can divide this. I'm going to use synthetic division to do this. So synthetic division. Okay, I'm going to write all the terms here, x cubed, x squared, x to the power 1, x to the power 0 up top. And you add your coefficients inside this little half a rectangle. And the coefficient here is 1. There is a 4 here, so don't be fooled by the ordering here. So there's a 4 here, there's a 1 here, and there's the negative 6. And the value of k that I'm going to add up on the outside is 1. So I'm going to bring down my first coefficient and multiply it. So 1 times 1 is 1. You add these coefficients afterwards. You get 4 plus 1 is 5. Then you multiply it. 1 times 5 is 5. Right? This is a 1, by the way. 1 plus 5 is 6. Then 1 times 6 is positive 6. And then you add them and you get 0. Right? Now the quotient is going to be 1 degree less. So this is going to be x squared, x to the power 1, x to the power 0, and this is your remainder. So what your quotient will look like, I'm just going to do that. Out here, your quotient will look like x squared plus 5x plus 6, right? And you can actually factor this as two numbers that add to 5x, or 5 that multiply to 6. You could do 2x plus 3x plus 6, right? Factor this by decomposition. X times x plus 2 plus 3x plus 2, and you get x plus 3 times x plus 2, right? So this is your factored version of your quotient. This was already determined as a factor, so therefore f of x, or the fully factored expression, is x minus 1 times x plus 3 times x plus 2. Okay, and that is the fully factored version of your expression. Alright, let's solve this polynomial equation. 3x cubed plus 2x squared minus 8x plus 3 is equal to 0. In order to solve for this, the first thing we need to do is we need to factor the expression here. And let's call this polynomial expression f of x. So in order to factor this, this is a cubic polynomial expression. Let's use the integral zero theorem. So using the integral zero theorem, we want to postulate potential factors, right? So if we're looking at potential factors that we need to test out using remainder theorem and thereby factor theorem, the potential factors are going to basically be the factors plus minus of the constant divided by plus minus the factors of the leading coefficient. Okay, so factors of constant over factors of leading coefficient. Now to do this, basically the constant here is basically the 3, right? So plus minus factors of 3 are 1 and 3. leading coefficient is also 3, so plus minus 1 and 3. So what we can test out is plus minus 1, 1/3, 3, right? So you're just dividing it by each number, right? So let's test out 1. 1 is always a safe bet. I'm going to do f of 1. So f of 1 is 3 times 1 cubed plus 2 times 1 squared. So once again, this is guess and check. For the most part, I would always test out 1 if it is a factor. And this actually works. So f of 1 is equal to 0, right? So because f of 1 is equal to 0, the remainder is 0. According to factor theorem, x minus 1 is a factor. So if x minus 1 is a factor, we can figure out the remaining factors by using synthetic division or long division, okay? So because the divisor here is linear, what I'm going to do is I'm going to use synthetic division just because it's faster, right? So this is x cubed, x squared, x to the power 1, x to the power 0, right? Maybe we should make some space there. Sorry about that. Okay, so this is x cubed, x squared, x to the power 1, x to the power 0. And you literally have to put some coefficients here. I just use the terms up top just for bookkeeping purposes. You have a 3 here, you have a 2, you have a -8, you have a +3. And your factor here is the 1. Right, so I'm going to bring this guy down. This is my leading coefficient. I multiply it. 1 times 3, +3. So then you add these coefficients, so you get 5. 1 times 5 is +5. -8 plus 5 is -3. And 1 times -3 is -3. And then when you add it, 0. The quotient here is basically going to be in the format of x squared, x to the power 1, x to the power 0, and this is your remainder, right? So your quotient is going to look like 3x squared plus 5x minus 3, okay? And in factored form, that's going to be times x minus 1, okay? So this is basically you factor. You can factor this guy further, right? So if I wanted to factor this guy further, right, you want two numbers that multiply to -9 that add up to +5. Well, there aren't any two numbers that do that. You can't really factor this. So we can just kind of stop at this point, right? X minus 1, this is equal to 0. Now you could solve this using quadratic equation. Let's see if there are solutions. So I'm going to use the discriminant method, right? B squared minus 4ac. As long as it's not equal to 0, then there are solutions present, right? Solutions would be possible. Right, so in this case, b squared, this is your a value, this is your b value, this whole thing is your c value, right? So if we test it, you get 5 squared minus 4 times 3 times -3, which is 25, plus, it looks like 36 is 41. So there should be two solutions. So you can actually figure out those two solutions using the quadratic formula. So x, if you let 3x squared plus 5x minus 3 equals 0, right, then x is equal to -b plus minus b squared minus 4ac over 2a, right? So this is going to be somewhat of irrational numbers, right? So we figured out what the b squared minus 4ac term is. It's 41. So the -b here is -5 plus minus square root 41 over 2 times a, which is 2 times 3, which is 6. So your answer, so x can be possibly -5 plus minus square root 41 over 6. So that's one of our solutions. The other solution here is x can be equal to 1. Okay, so therefore, right, x can be equal to -5 plus minus 41 over 6, or x is equal to 1. Okay, so that is our solutions for our function. So that's how we can solve our function, right? So first you would factor this, and then you can just equate each factor to 0 and solve. Alright, let's solve for x in 5x to the power 4 is equal to 7x squared minus 2. Well, what you want to do is, in order to solve, what you need to do is move all terms to one side. So I'm going to move this and this term to the other side. So you get something like this. And let's say that this expression, this is a polynomial expression. Let's call this guy f of x. So in this case, you need to fully factor this first, and then you can solve for it. So if I want to fully factor this, I'm going to use a combination of remainder factor theorem and some form of division, right? Either synthetic or long division. Now, this is x to the power 4, so I actually need to find two factors, right? Or you could do synthetic division twice. I'm going to find two factors and employ long division. So if I'm looking at f of x is equal to 5x4 minus 7x squared plus 2, right? Let's use the integral zero theorem, IZT, to find potential factors. So the potential factors here are basically factors plus minus the factors of the constant over plus minus the factors of the leading coefficient okay, so this is basically going to give us plus minus factors of constant, which is 2, so 1 and 2, leading coefficient plus minus 1 and 5, right? So some of our potential factors are plus minus 1, 1/5, 2/5, and 2. Okay, let's try positive 1 first. I think that's usually like a off the bat kind of choice to pick. So let's do f of 1. So if you do f of 1, you get 5 times 1 to the power 4 minus 7 times 1 squared plus 2. You can actually notice that it's 0. So f of 1 is equal to 0. So according to factor theorem, x minus 1 is a factor. Okay, then what you want to do is you want to test at f of negative 1. So if you do f of negative 1, you get 5 times negative 1 to the power 4 minus 7 times negative 1 squared plus 2. And you can actually notice here that this also gives you 5 minus 7 plus 2, right? I'm just going to erase that, which also gives you 0. So f of negative 1 is also 0. So this tells us that x plus 1 is a factor. So therefore, x plus 1 and x minus 1 are factors, and if you multiply these two collectively, you expand it, or you can use FOIL, or you can think about a plus b times a minus b, which gives you a squared minus b squared. Well, this gives you x squared minus 1. Okay, so this gives you x squared minus 1. Now, because this is a factor of our expression, or our quartic expression here, but this is not a linear divisor, then you can use long division to solve for the remaining factors, right? So if you're looking at this, I'm just going to do it out here. Okay, so your dividend here is 5x to the power 4 minus 7x squared plus 2, right? And your divisor here is x squared minus 1. And the name of the game here is to match the first term, basically the leading coefficient and the leading term, right? So to match that, I'm going to multiply this by x squared, because we can understand that x squared times x squared minus 1, if you expand this out, you get x to the power 4 minus x squared, right? So I'm going to write that, sorry, I should multiply that by 5x squared, because you get 5x squared minus 5x to the power 4 minus 5x squared, sorry about that. Right, so you have to match the term as well as the degree, so you get 5x to the power 4 minus 5x squared. Then you subtract the 2, right? So 5x to the power 4 minus 5x to the power 4 is 0. Negative 7x squared minus negative 5x squared. So you have to make sure you do the integer operations properly, right? So you get negative 2x squared here. Then what I'm going to do is I'm going to bring down the positive 2, and then you want to match the leading coefficient, basically this leading term here, right? So you want to match the leading term, so I'm going to multiply this by negative 2, so you get negative 2x squared plus 2, and you can see that everything kind of cancels out, right? So this negative 2x squared and negative 2x squared cancel out, and the 2 and 2 cancel out, so it's 0. Okay, so this is your quotient. So collectively, this is what you'll get. You'll basically you should get something like this. We'll just let's use a different color. So you should get 5x squared minus 2 times x squared minus 1, and you can factor this back to its original state. X squared, 5x squared minus 2, x plus 1 times x minus 1, right? So this is your new expression, right? So you can equate this to 0, so you can see that therefore x is equal to plus minus 1, so negative 1, positive 1. You can also solve for the 5x squared minus 2 is equal to 0. Move the 2 to the other side. 5x squared is equal to 2. divide by 5 to solve for x. So x squared is 2 over 5, and if you square root it, right, so x is equal to plus minus square root of 2 over 5. Okay, so this is also equal to plus minus square root of 2 over 5. Okay, so basically those are our solutions, right? So you can also include this guy as well. Okay, so that's how you can, if you plug these values in, you should satisfy the equation. Alright, rectangular in-ground pool is to be installed. The engineer overseeing the construction project estimates that at least 1,408 meters cubed of earth and rocks need to be excavated. What are the minimum dimensions of the excavation? If the depth must be 2 meters more than 1/4 of the width, the length must be 12 meters more than 4 times the width. Okay, so excuse me. Let's identify some variables here. So I'm going to let x represent the width in meters. And we can understand that the depth is 2 meters more than 1/4 of the width. So I'm going to let 1/4 x plus 2 represent the depth, because it's 2 meters more than 1/4 of the width, and this should still also be in meters. And also the length must be 12 meters more than 4 times the width. So let 4x plus 12 represent the length in meters. Okay. So what we want to do here is we want to find the dimensions of the excavation, and we also want to understand that the volume here is given as 1408 meters cubed. And we know that volume, and this is assuming that this is a rectangular pool, so it's a rectangular prism, right? Volume of a rectangular prism here is length times width times height. So I'm going to create a volume equation as a function of x, right? So volume of x is equal to length, which is basically 4x plus 12 times width, x times height or depth, which is basically going to be 1/4 x plus 2. Okay, now we can see that volume is purely a function of x now. And what I want to do here is I'm going to expand this guy out, right? So v of x is equal to 4x squared plus 12x times 1/4 x plus 2. Okay, and at this point what you want to do here is you want to expand this guy out. Okay, so I'm going to expand this and this out, and then this guy and this guy. Okay, so when you multiply this, when you expand this guy out, you get 4x squared times 1/4 x plus 4x squared times 2 plus 12x times 1/4 x plus 24x out here. Okay, so 4x squared times 1/4 x is basically x cubed, right, because the 4's would cancel out, and you get 8x squared plus 3x squared, right, 12 divided by 4, 3x squared plus 24x. Okay, collect the like terms, so you get x cubed, x cubed plus 11x squared plus 24x. Okay, now this is basically your volume as a function of x. We also know that the volume here should be equal to 1408 meters cubed. Okay, so I can equate that. So x cubed plus 11x squared plus 24x is equal to 1408. Okay, and now what you want to do is you want to solve for x, and the only way to solve for a polynomial equation, you got to set one side equal to 0. So I'm going to get x cubed plus 11x squared plus 24x minus 1408 is equal to 0. Now, in order for us to solve this polynomial equation, we actually need to factor this fully. So in order to factor this fully, we actually need to figure out one of the factors first, right? Now, a really quick way of doing this, we can actually use the integral zero theorem, right? And the integral zero theorem basically states that the potential factors that we can have are plus minus the factors of the constant, so 1408, divided by the factors of the leading coefficient. Now you can imagine that there is a lot of these factors. So I'm just going to write a couple of these guys, excuse me. So you have plus minus 1, 2, you can also have, it looks like 4, right? 1408. Yeah, we can have 4, right? We can have 8, right? And let's just keep going like that, right? And then this is divided by our leading coefficient. Now you can imagine that there's a lot of potential factors that can probably go into this number, right? Like 16 is also another one of them. To narrow down our potential factors, the values that we can test into a remainder theorem, what we can do is there's basically a shortcut method here. As long as a is equal to 1 in an expression of ax cubed plus bx squared plus cx plus d, you want to find certain potential factors, specifically 3 potential factors that can add up to b. Okay, and out of those 3, one of those will actually be a potential factor. So it will be actually an actual factor, not a potential factor, right? So in this case, our b value is 11. Okay, our b value is 11, and out of the potential factors, you want to find 3 that add up to 11. So we can actually notice here that 8, 2, and 1 can potentially add up to 11. Now you want to consider plus minus 8, 2, and 1. So out of these 3, at least 1 will be a factor, an actual factor. So let's figure out which one actually is a factor. Whoops. Let's go back to there. Right, so in order to do that, what I'm going to do is I'm going to test each case out, right? So I'm going to do f of 1, and if I do f of 1, I get negative 1,372. Okay, so basically I'm plugging it into my equation here, right? And in this case, f of x specifically would be this. Okay, so this is my f of x, which is x cubed plus 11x squared plus 24x minus 1408. Okay, so I'm plugging it into this, and you can keep testing them out. You can try f of negative 1, but it looks like it won't work. Eventually, if you plug in f of 8, you'll get 0. Okay, so you can imagine that, right? You want to find out of the potential factors, as long as a is equal to 1, you want to find 3 numbers that add up to the second term b. Okay, and out of those 3 terms, at least 1 will be an actual factor. So f of 8 is equal to 0. We know that the factor is x minus 8. Now what you want to do here is you want to test to see if there are any other potential solutions, because we know that if x minus 8 is a factor, right, one of the factors, if you did factor this fully, is x minus 8. And because you have x minus 8, you can say that x is equal to 8 meters. That's one of the solutions. But we want to figure out if there are other solutions present, right? So what we want to do now is let's do synthetic division, right? So I'm just going to kind of erase this to make a little bit of a space. So I'm just going to erase some of this out. Okay, let's do synthetic division to see if there are any other potential factors, right? So you're going to do the synthetic division setup where we know one of our factors is 8, right? This is x cubed, this is x squared, x to the power 1, x to the power 0. I'm going to write the coefficients. There's a 1 here, there's 11 here, there's a 24 here, and there is a negative 1408 here. So I'm going to bring down the leading coefficient, multiply it with my k values, so you get 8 here, you get 19. 8 times 19 is basically 152. Okay, add these two together, so you get 176, and 8 times 176 is actually positive 1408. So the remainder here is 0. So your quotient here is basically x squared plus 19x plus 176. Right, and you can actually notice that this isn't factorable, and if you do try to solve for this using the quadratic equation, right, you can notice that it's not, you're going to get decimal values, right? So we want discrete values. So technically, if I did factor this out, right, all of this can be written out as x minus 8 times x squared plus 19x plus 176 is equal to 0, and therefore x is equal to 8. Right, so if x is equal to 8, we know that the length is, we know the width is 8 meters, right? So therefore the width would be 8 meters. The length here would be, we said the length here is 4x plus 12, so 4 times 8 plus 12, which is 32 plus 12, which is 44 meters, right? So the length here is 44 meters, and the depth or the height here is basically 1/4 x plus 2, so 1/4 times 8 plus 2, which is 2 plus 2, which is 4 meters. Okay, so these are the dimensions of the pool. Okay, Mary asks you to help her find a specific box. The height of the square base box should be 2 centimeters more than the side length of the square base. Mary wants to personalize the box. She changes the side length of the square base to x centimeters. What would the volume of the box be? For part B, if the volume of the box is 16 centimeters cubed, what should the side length of the square base be? Okay, well, if this is square base, okay, so the box's square base is dimensions of x, and the height, h, should be x plus 2, right? So the volume of the box, therefore, as a function of x, should be length times width times height, right? So this is the length, width, this is the height. So it's x times x plus 2. Okay? So in this case, whoops, this is going to give me x squared times x plus 2, right? V of x is x cubed plus 2x squared. Okay, so this is the volume of the box. So this is part A. Now for part B, if the volume of the box is 16 centimeters cubed, what should the side length of the square base be? I'm going to let the volume of the function v of x equals 16. So x cubed plus 2x squared is equal to 16. I'm going to move the 16 to the other side. X cubed plus 2x squared minus 16 is equal to 0. And then what you want to do here is you want to solve for this equation, right? So this is a polynomial. It's a cubic equation, and in order to do this, you should factor this out. And the easiest way to factor this out is we want to use remainder and factor theorem, right? So I'm going to use remainder and factor theorem. If I look at potential factors, right, you're looking at potential factors of the constant, so it's 16. So 1, 2, 4, 8, 16 divided by the factors of the coefficient. So I'm going to test some of these values out. So if I test some of these values out, you can find that f of 2 actually is equal to 0, right? So you can do this just by guessing and checking, right? So f of 2 is equal to 0. So in this case, x minus 2 is a factor. If x minus 2 is a factor, you can use synthetic division or long division to find the remaining factors. So I'm going to use synthetic division here. Just going to do it out here. Okay, so I'm going to put 2 up here, and then I'm going to write down each of my terms. So x cubed, x squared, x to the power 1, x to the power 0. So this is a coefficient of 1, this is 2, this is 0, this is negative 16. And then I'm going to bring down the first coefficient. You do 2 times 1, which is 2. You add the 2 together, so this is 4. 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. Negative 16 plus 16 is 0. So your coefficient is going to have the terms 1 degree less than the dividend. So x squared, x to the power 1, x to the power 0, the remainder, right? This is 0, by the way. Remainder 0 means it's a factor. And in this case, our quotient is going to be x squared plus 4x plus 8. You can attempt to factor this. In this case, this actually isn't factorable, so you can just leave it like this. So one of your values, x minus 2, the other value is x squared plus 4x plus 8, right? And this is basically your volume function. So this is another way you can write your volume function. If you set this equal to 0, therefore x is equal to 2, right? So if the side length of the square base is going to be 2 by 2, right? And the height should be basically 4. Okay, so because x plus 2, right? So the side length of the square base is going to be 2 centimeters.